ready to go. So this is the first of a series of talks that come out of one of the work packages in ECOKNOWS, which has been looking at eliciting and valuing uncertainty. And so over the next couple of days, Polina, Atso, Margarita will also be talking and giving rather more specific results of some of the efforts in that area within the ECOKNOWS project. What I want to do is to give a bit of a there we go. Okay, so what I'm trying to do is to illustrate a number of ways of presenting outcomes and uncertainty, and to make some comments on those, and drawing on our experience across ECOKNOWS and also some work we've done with ICAT and in the MyFish project. And I think it's particularly useful to look across the several projects because they focus on different things. So in ECOKNOWS, we've been particularly focusing on uncertainty and assessment. With ICAT, we particularly were focusing on uncertainty in relation to management. And in the case of MyFish, we're looking at goals. And it's very important to be looking across all of those. So first of all, just to define a bit about what risk is. There's a definition here from Bergman about risk being a chance within a particular time frame. And one of the issues here is that time becomes one of the dimensions. And in a policy sense, you can think about achieving results over different lengths of time. And that's something that I'll illustrate a little bit further on. Also, we can only assess uncertainty in some cases. We can't quantify it in all cases. How we represent uncertainty is quite an important issue. We've already heard about the way that it's a perception, it's in your mind, and the way that it's presented in your mind and thought of in your mind is important. So whether you're thinking of it as a percentage or a fraction can make a difference. Whether you present it as visual images in bars or pies, that can be important. And ultimately, the strength of our perception is also important. That we should recognize that individuals, whether they're experts or lay people, are not very good at making estimates of risk. They tend to be biased, overconfident, and inconsistent. We'll see some examples of that in some of the other talks from this work package. So starting to look at some of the ways in which outcomes are presented, we've particularly looked at icon arrays, and here's an example of one of these. Gets attention, it's very visual, but in this case doesn't tell you anything about uncertainty. So in fact, it emphasizes certainty of outcome. Here's another example of using icon arrays, but in this case, it's emphasizing the difference between large and small-scale fisheries in Greece and the outcomes across a number of different dimensions. It, again, doesn't give you anything about uncertainty within it. It's simply showing that there are trade-offs. Now, the climate change sector, which has already been mentioned earlier by Samu, been very good, I think, in terms of the way that they present uncertainty. They put a lot of effort to identify uncertainty and to present it. And this is an example of a way that they've done it, where you've got temperature charts, effectively, to highlight what the risks are in a number of different dimensions. So you've got a single indicator, that is change in temperature, with various uncertainties around different scenarios on the left. So a single indicator, but then a number of different dimensions of risk impacts on the right. And that allows you to take in the time dimension because you can look at the indicator and where it is at different times into the future. That's very, very important for a policy outcome where you could decide to achieve a certain goal within 10 years, 20 years, or whatever. At ICAT, they've been very good at using graphics to illustrate uncertainty. And I guess the scary thing about this is the amount of uncertainty that there actually is. So if you look here at this yellowfin tuna Kobe plot, it's looking at an assessment for a single year, and you can see the distribution goes through three different parts of the plot, from dangerous to good, and you could be anywhere within that range. So it highlights the importance of uncertainty there in terms of where you are at a particular time within just assessment. If you then look forward into management, this is for bluefin tuna rather than yellowfin. What this strategy matrix does is compare different TACs down the left, in the vertical axis on the left, and it looks at the likelihood of achieving getting into the green space in a Kobe diagram at a certain time into the future. So you can trade off time and the degree of confidence of getting into an acceptable position. And what you see here is that uncertainty increases as you look further forward into time, but while it's more uncertain, it's actually more satisfactory. So you've got time to recover, but the uncertainty increases. So the amount of the recovery is more variable. Now, another way that they've tried to present this uncertainty into the future is, I think, very effective in demonstrating the evolution of risk. Risk isn't just static. It's going to change over time as you get more information. And Samu demonstrated that very nicely this morning with some of his examples. So here's a series of pie charts that show the proportion of the likelihood of achieving different quadrants within the Kobe diagrams years into the future for a bluefin tuna stock based on a 2010 assessment and then based on a 2012 assessment. And you can see that over the 2 years, more information came in that in this case made the same management more likely to achieve a satisfactory result over time. Now, this illustrates pretty well the change in the risk. What it doesn't illustrate is what you actually do about it, because that's going to be tied to your goals. So you could look at that and say, well, we could fish more because we can accept the risk. Or you could say, well, this is a chance now to capitalize on the fact that we've reduced risk and change the risk target. Or it might say, let's bring forward our objective and try and achieve a target in a quicker time. So the illustration of the outcome doesn't necessarily tell you what to do any better. Now, one of the things we've been looking at with ICAT is to say, how can you characterize and present the uncertainty of all the different components of the models that they use to decide on management for tuna. And so this just illustrates 4 examples of those. And the dimensions are on the left axis, importance, going from minimal up to massive, so the importance of uncertainty. The horizontal axis is the degree to which uncertainty is represented in the models. So again, going from very well on the left to very poorly represented on the right. And then the size of the hoop is an expert's opinion of the level of uncertainty, the level of knowledge uncertainty that might be amenable to improvement. So what these 4 illustrate is different levels of consensus amongst experts in those 3 dimensions. So you can see for natural mortality, there's pretty good consensus. Most people agree it's important, that it's poorly represented, and that there's quite a lot of knowledge uncertainty there. So you get down to the one in the lower right, the risk attitude of managers, no consensus at all. It may or may not be important, it may or may not be well represented, and there may or may not be a lot of knowledge to be gained. So the question then is, having characterized it, what do you do about it? And of course, there are really 2 ways in which an organization like ICAT can respond. One is through something like MSC, testing the approaches, or additional research. And what we should expect is that MSC might change the position on the importance and represented axes, but it won't change the size of the uncertainty, whereas research would actually do that. So if we look then at what the outcome might be, you've got a prior set of beliefs about importance, representedness, and knowledge uncertainty, so this is the size of the hoops and their position on those other 2 axes. MSE is likely to bring them all together and push them up in terms of, or over to the left rather, in terms of being well represented. Doesn't necessarily mean that they're going to be any more important. Whereas research is going to make each of the hoops smaller. So you can represent the degree of change in those various dimensions that way. Hopefully see some progress. In the MyFish project, we've been looking at evaluating management options in mixed fisheries and looking at quite a range of different types of management options and also looking at different goals. And the one I'll illustrate here is looking in the Baltic at a cod, herring and sprat fishery that's combined. There are several different objectives being compared here, so a maximum economic yield without constraints, one that's got sprat conservation as a high-level goal, and another one where you want sprat conservation and more equitable revenue. So that would be quite complex to optimize, and of course you could do it. You can do it in terms of computing, but you still need to interpret the results, and so the presentation of how those results appear to the people who have the goals is important. So we looked at two ways of doing this. One which is just the raw model outputs, which are not readable here, but the columns are the different management objectives and then different outputs directly from the models in the rows. Now, you can compare that then with a more visual approach where we've simplified down and said, okay, what are the actual important bits out of that table of raw model output? Put it into a graphic form because we want to be able to take this to a range of stakeholders who may or may not be particularly quantitatively inclined. And we also want to express uncertainty. And so this icon array demonstrates through the shading the degree of uncertainty that there is. It also illustrates with the red color the fact that sprat in the first column are not meeting a particular objective. So you would be in your trade-off sacrificing that objective of sprat conservation. So we think that this use of icon arrays and of pie charts here at the bottom is effective in that respect. Now, another thing that we've been doing in MyFish is to think through how you express uncertainty in the goals in fisheries. So it's not just in assessment that there's uncertainty and in the management performance that there's uncertainty, but there's also uncertainty about what people are trying to achieve. And in workshops with a range of stakeholders, we've ranked different objectives according to the feasibility and their overall importance. And so you can get from a group of stakeholders a distribution of relative weighting, which might then be useful in terms of trying to optimize across a range of different outcomes. Another thing that we've tried to do within MyFish is to come up with an operational decision framework. And I just want to try to highlight here where there's a flow of the need to present uncertainty, or a flow of uncertainty that goes through this from the problem framing, which is largely about assessment, options and implementation, which is largely about management, and evaluation, which is about goals. So you need to be thinking about uncertainty at each of those stages, and I think planning for it. So the models need to be heading towards the uncertainty at the next step. So an assessment model needs to be looking ahead to uncertainty in management and uncertainty in evaluation. So finally, just to finish off here, uncertainty is high, and it's very important to be able to communicate it. Having some visual method of doing that is important for those that are not particularly quantitative. It comes up in scientific data. It also comes up in the social and management objectives, and it's got to be done in lots of different dimensions. So there's not going to be one easy way to do it across every dimension. And finally, that there needs to be research on how to communicate risk as well as in how to do the assessment. So it's not just coming up with assessment models or management models. We need to be also thinking about how to communicate the risk. Thank you.